Hello, my name is Jerry Lee, and for this 420 word speaking assignment, I'll be reading Chapter 1 of Neil deGrasse Tyson's Origins. In the beginning, there was physics. Physics describes how matter, energy, space, and time behave and interact with one another. The interplay of these four characters in our cosmic drama underlies all biological and chemical phenomena. Hence, everything fundamental and familiar to us Earthlings begins with and rests upon the laws of physics. When we apply these laws to astronomical settings, we deal with physics writ large, which we call astrophysics. In almost any area of scientific inquiry, but especially in physics, the frontier of discovery lives at the extremes of our ability to measure events and situations. In an extreme of matter, such as the neighborhood of a black hole, gravity strongly warps the surrounding space-time continuum. At an extreme of energy, thermonuclear fusion sustains itself within the 15 million degree cores of stars. And at every physical extreme, we find the outrageously hot and dense conditions that prevail during the first few moments of the universe. To understand what happens in each of these scenarios requires laws of physics discovered after 1900, during what physicists now call the modern era, to distinguish it from the classical era, which includes all previous physics. One major feature of classical physics is that events and laws and predictions actually make sense when you stop and think about them. They were all discovered and tested in ordinary laboratories in ordinary buildings. The laws of gravity and motion, of electricity and magnetism, and of the nature and behavior of heat energy are still taught in high school physics classes. These revelations about the natural world fueled the Industrial Revolution, itself transforming culture and society in ways unimagined by generations that came before, and remain central to what happens, and why in the world of everyday experience. By contrast, nothing makes sense in modern physics, because everything happens in regimes that lie far beyond those to which our human senses respond. This is a good thing. We may happily report that our daily lives remain wholly devoid of extreme physics. On a normal morning, you get out of bed, wander around the house, eat something, then dash out the front door. At day's end, your loved ones fully expect you to look no different than you did when you left, and to return home in one piece. But imagine yourself arriving at the office, walking into an overheated conference room for an important 10 a.m. meeting, and suddenly losing all of your electrons, or worse yet, having every atom of your body fly apart. That would be bad. Thanks for listening to my 420 word reading assignment.